that's not necessarily contrary to the concept of a Big Bang, where, all of the universe came out of a teeny dot smaller than an atom, and, and returns to it eventually. And so I didn't know all this, but I just thought, oh, my God, I could imagine that if I looked at the Earth from far, or the bus that was bringing me home from far, that it would look like a dot, and then eventually the Earth would look like a dot, and if I look further, the solar system would look like a dot, and the galaxy would look like a dot, and so on. And then I could imagine that all the cells in my hand would look like dots, and then if I flew in one of those, I could see that it would be made out of billions of little atoms that would look like dots, and that these atoms were probably made out of smaller dots in the center, and so on. And I thought, oh, it's dots all the way up and all the way down.
Yeah, it depends on your perspective in a way then.
Yes, it depends on your perspective. It's scale dependent. And so basically the universe makes little dots and then assembles the dots together to generate all the complexity we see. But that the source of all of this is this point, which eventually I came to call a singularity, which is a little point of infinite density, or a mini black hole. And so I started to think that, everybody in the bus I was in was made out of smaller dot that were made out of smaller dot, and so on to infinity. And I started to think, oh, everything has this infinity within it. And I got really excited. And I talked to my mother about it, and she had some objections. And her objection is like, if everything is infinite, how is it that they seem to be finite? Like the table, a table doesn't seem to have infinity in it, or the pen I'm holding, and all these things. And it took me back. It took me a while to figure out how infinities and finite system could be compatible. And I didn't know at the time, but this is a fundamental question in physics. It's actually one of the biggest riddle in current advanced physics. How is it that infinities and finite systems interact? We have a theory for all the big things in our universe that tells us that it seems to be a continuum. This theory is Einstein field equations. It's very renowned. It has shown to be very appropriate and exact in many ways. And then we have a theory for the small things, like anything smaller than a molecule, like atoms and subatomic particles. That's called quantum theory. That tells us that everything is quantized, that it has finite boundaries.
Yeah.
And, and the two don't agree, because one says it's a continuum and the other one says it's finite and it has boundaries.
Right.
And that's a big chasm in our physics. And since this physics have been written for almost 100 and some years, we've been looking for a unification theory, a theory that would unify the big with the small.
Right.
Because obviously big things are made out of small things.
That's right.
So it was obvious to me that there must be a theory, there must be an understanding, and although I didn't know all this complexity about advanced physics and all this, I felt like I had to find a way to put infinities and finite systems together. And eventually I came to it. And I came to it through geometry. I started to study a lot of geometry. Interestingly, I studied a lot of ancient texts, and many of the ancient texts talk about geometry. I study ancient schools of thoughts, like the Pythagorean schools, the Platonic schools, and all this. And I came to realize that there's a set of geometry, a very specific set of geometry, that produce fractal systems, that in which infinities and finite systems are interacting together in a compatible way, where you need a boundary to define infinities, and you need infinities to define boundaries. And so the listeners if they have a pen and a piece of paper, they could doodle this. But I'm going to try to explain it without visuals, which is a little difficult. But
sure.
If you make a circle on a piece of paper,
right,
and you were to put a triangle in it, and then you put a reverse triangle, you have something like a star, a six-pointed star in a circle.
Right.
Or like a Star of David in a circle.
Sure.
And so imagine that you went to each of the corner of that star and you made a smaller triangle. You could get smaller Stars of David to appear. And so you could make like little Stars of David inside that big Star of David, and each of these little stars would have a little boundary around it, a little circle around it.
Mm-hmm.
And then you could do smaller circles again on that smaller Star of David and get smaller Stars of David, and you could put a circle around that and get another boundary. Those would be resolutions in the structure of the fractal systems. Each one defines a scale. And you can continue to do that to infinity, meaning if you give that program to a computer, and you said to the computer every 5 iterations, zoom in to one of those boundaries, and then continue, and then zoom in again, and then continue, and zoom in and continue. The computer could continue to do this to infinity. Yet, you would never, ever, ever, ever exceed the first boundary that you've made for yourself.
Mm-hmm. Right.
The first circles you've made. So, within the confine of a circle, which could be a sphere, you could do it with a sphere and tetrahedrons.
Yeah.
You can put infinite amount of divisions. You can put infinite amount of information within what seems to be a finite space.
So this is it a little bit similar to like the Mandelbrot set that you can just go into it and into it and into it?
Yes, absolutely. And the geometry of it and how it divides, it's seemed to be intuitively correct at first. And the reason is because when you look in nature seems to do things that way. If you look at the branches of a tree, if you look at the way flowers emerge, it seems that fractal systems are found in nature everywhere.
Mm-hmm.
And so, to me, that was a very important clue, that nature probably uses some of these fractal concepts to produce creation. But what intrigued me was, where would that be? Meaning, where is the geometry coming from?
Right.
Like how... Go ahead.
Oh, no, I just said right, so please go ahead.
Yeah. How does it emerge? And, where is it coming from? And so that took me longer. I had to start studying a lot of physics and all this, and eventually I realized that when we think of reality, we think of reality as what's there. Like, for instance, a tree, a plant, a house, a phone, a wallet, whatever is around, you say, oh, that is there. Yeah. That is real. However, for instance, we know that there's all sorts of electromagnetic fields and all this that you don't see, but or you don't experience directly, but that doesn't mean they're not real. For instance, we know that if they're strong enough, they can do all sorts of real things, including carrying information across long distances, radios, televisions, and all this.
Yeah.
So there's an unseen reality that has real physical effects as well. Well, I started to realize as I studied physics that there may be another level of unseen reality that we don't directly experience. And that reality, that level of